Hello, my name is Aratrik Maiti. I am from West Bengal, Chandanagar. I completed my BSc Honours degree from Shirampur College in 2024. I gave IIT JAM exam conducted by IIT Delhi in 2025, and I scored an AIR of 370. After that, I applied for IPhD interviews at various institutes. SN Bose was one among them. I got shortlisted for the interview. The interview was conducted on 26th May 2025, and for the I was selected to um, join the SN Bose Institute. So right now I want to share my interview experience with you, and I hope that it helps you all in the long run. So, sir, can we begin? So the first question from my okay, so before I start with the questions, the first thing was that my panel consisted of a large number of teachers. There were at least 7 to 8 teachers, and they were all asking me questions. They asked me my area of interest, to which I said that I didn't have an area of interest outlined, so I want to explore some areas further. And after that my interview started. So the first question, as shown on the screen, I was given two equations: y prime, which is dy dx equals to minus 4x, and y prime equals to y. So they asked me to solve these equations and determine the type of motion. First, I just wrote down the equations in notation form, and by some simple substitution, I arrived at the conclusion that d2y dx2 is equals to minus 4x. And as we all know, this is a simple harmonic motion. So yes, after that they asked me to solve this equation, so I started solving. So we take y equals to e to the power alpha x. Now we substitute in the equation, and after some calculations we get alpha squared plus 4 equals to 0. So we get alpha equals to plus minus 2y, and we need to write the equation in linear form. So y is equals to c1 e to the power 2ix plus c2 e to the power minus 2ix. So this was my form. So this can be further broken down by using de Moivre's theorem. So c1 cos 2x plus I sin 2x plus c2 cos 2x minus I sin 2x, and we just group the same terms together and we arrive at the final line, which is a cos 2x plus b sin 2x. So after this, actually, there was one more sub question. They gave me two boundary conditions to solve this and plot the graph. But the thing is that I unfortunately forgot the boundary conditions. So sorry for that. So I hope we can move on to the next question, which is question number two. So I was given a matrix, 2 cross 2 matrix, which is A equals to 1, 1, 1, 1. I was asked to find the eigenvalues and rank. So what I did was use the characteristic equation. We used a modulus of A minus lambda I. And after that, so just a basic determinant solution, which gives us a quadratic equation. And on solving the quadratic equation, we get two eigenvalues: lambda equals to 0 and 2. So these are the eigenvalues of the matrix. Um, and I was also asked to find the rank. So in order to find the rank, um, what we need to do is row reduction. Row reduction is a technique which is commonly used to find rank in a matrix. So just we deduct the elements of row 2 minus row 1, and we see obtain a matrix which is 1 1 0 0, and we see that this matrix contains only one, like has only one row which has non-zero elements. So the rank of the matrix is 1. So this was my second question. Sir, can we move on to the next page? Yes. So now I was asked a third question, which is again related to the matrix. So basically, I was given a matrix A, which consisted of n ones. Like it was an n cross n matrix with consisting of all ones. So again, I was asked to find rank and the eigenvalues. The thing is that rank is the same as the previous one, because by row reduction, all rows except one become 0. So the rank is 1. And so previously I had used the like characteristic equation to find the eigenvalues, but this time, since this is a similar matrix, we just use the similarity between the two matrices. So what happened was that previously our eigenvalues were 0 comma 2. Now for 2 cross 2 matrix we have two eigenvalues, of course, as is the rule. And in n cross n matrix we will have n eigenvalues. So previously our eigenvalues were 0 and 2, which now 2 corresponds to the trace of the matrix, which is the sum of the diagonal elements. So over here we have n eigenvalues, of which n minus 1 will be 0, and we will have one non-zero element which is equals to trace of the matrix. Again, this can be traced back to the previous problem, and we can just surmise this from there. So what we have is 0 comma 0 comma 0, n minus 1 0, and 1 n. So that is the answer to this question. Okay. So that was all from mathematical physics. And now one professor asked me if I knew about black body, and I said yes. So they asked me to draw the intensity versus frequency spectrum. So the intensity versus frequency spectrum graph is clearly shown in the like in the PDF or the pages. As you can see that the with like as the temperature rises, the peaks shift from origin towards higher frequencies. So after this, they asked me one question. So the question was, how can we measure the temperature of a star from this graph? So explain the law used. So this was a astrophysics based question. So what we did was we simply used Wien's law. So Wien's law is as written: lambda 1 T1 equals to lambda 2 T2 equals to a constant. The value of the constant is 0.29 centimeter Kelvin. Now, so what we have to do is just measure the wavelength of incoming radiation from the star and divide it by the constant. The boxed equation will give us the temperature of the star. So there was another sub question related to this. So sometimes the question was that sometimes if we try to measure the temperature of the star by this method, we find that the measured temperature is quite different from the original temperature. This is a phenomenon which happens. So why does this happen? So basically the thing is, this phenomenon happens because the wavelength changes with refractive index when the wave travels from space to our atmosphere. So what happens is, we know that lambda is v by f and n equals to c by v. So these are our two equations, right? Then by some simple substitutions we arrive at the conclusion that lambda equals to c by nf. So what is lambda? Lambda is wavelength, c is speed of light, n is the refractive index, and f is frequency. Now as we know, or as we have known, that the frequency emitted does not change. So the frequency cannot change. So what changes? Only thing that changes is wavelength. So since the rest is a constant, we surmise that lambda is directly proportional to 1 by n, or lambda is inversely proportional to n. So this was a reason why this phenomenon can happen, according to me. And they seemed satisfied with the answer, the professors. So after that, my final question was, they asked me about the experiments which I had conducted in BSc. Then I said photoelectric effect, and they asked me some detailed questions. So one of the questions they asked me was, what do you measure from that experiment? Like while I conducted an experiment in my lab, what did I measure? So I said that I measured Planck's constant, and they asked me how did I do it. So I said that we just need to find the cutoff voltages and plot them, and we need to get the slope, and from the slope we can measure the Planck's constant, which can be often brought down to the Millikan's experiment. This is known as Millikan's experiment. Millikan did it first in 1923, and he was also offered the Nobel Prize for this experiment. So basically that was all I was asked. And one more thing they asked me was that, did the value of the Planck constant, which I measure, come out as expected? And I said that no, sir, there were some not magnitudes, some orders of error. And they asked me, how did the error come by? I tried to say that a lot of heating can happen, which leads to these sources of errors in the experiment and can cause to be problematic. And that was all. So this was my interview experience. I would like to thank Shotto sir for this opportunity to like help me share my experience. So yes, thank you, and thank you, Physics Galaxy.